All right, so welcome back. Today we are continuing with the same example that I started last time. Just making sure that the mic and everything is working. Yep, good. All right, so remember this motivating example where we had n points in the Euclidean plane, and we wanted to determine which ones were the closest to. And we did come up with a full algorithm here. And we did a full analysis. Ultimately, we said that it was a quadratic algorithm because we ran over every single possible pair, right? So what I want to do now is I want to actually program it, right? So I've got here we go. I've got an editor open. Let's go ahead and program this in Python. Before we do that, though, I want to talk about how you're going to ultimately submit stuff to the web grader and to the web hand-in and the web grader. Because I don't require any specific programming language other than you can't use Java, and I recommend against using C. You're going to have to set up your own scripts in order to specify how your program should be run. And to do that, we've given you several examples. So for example, if you wanted to do it in PHP, right? Then there's this this PHP script that simply prints out hello world and the command line arguments and stuff like that. Whatever your actual program is going to be, you put it into this, into whatever script, and you can call it whatever you want. We don't care. The only rule is that you also have to provide a run.sh file, and it does have to be named run.sh all lowercase. And the contents of that file is a script that tells you that it's a bash script. So this is called a shebang. It's a comment followed by an exclamation point that tells the system that you should run this script as a, and then whatever follows here in a bin bash. You may or may not be able to get this to run on your own computer because you need bash installed. If you've got a laptop, if you've got a Mac or something like that, it'll probably work. If you've got Windows, it probably won't work this way, but that's how it needs to work on CSE. So if you're working on CSE, then this will definitely work because that's where bash is located. And what follows is just how you would run it from the command line. For example, in this example, I would run PHP. I would run the script called hello.php, and then this quotation, $, and @ that passes through all command line arguments that were given to the run.sh file into your script, because everything is going to be command line arguments. Okay. Now let's look at some, hopefully, how many people have decided on Python 3, hopefully? Okay. All right, the vast majority of you. Then let's go ahead and take a look at what that looks like. So here's a hello.py file, right? Hello world, and you passed, and then we print out all the command line arguments here. The run.sh file for this one looks like Python 3 hello.py, and then the same pass-through of command line arguments. Now I've got a bunch of directions here, but on CSE, Python 3 is not the default. Weird, but it's true. Instead, what you need to do is you need to explicitly use Python 3 in order to execute Python 3. You can have multiple versions of Python installed on your system, and they can live happily together in harmony. But there's got to be one default. If you just use Python, then you're going to end up using Python 2. And if that's what you want to use, then go ahead. But I would highly recommend that you use Python 3. Yeah?
Why do we need to pass command line arguments to this? Is it just going to be like this every time?
Well, if we need to pass in a file name for you to open up for the input, right, then we're going to pass that to your run.sh script. That needs to be passed to your actual script, your hello.py or whatever.
Is it okay if we just basically copy paste this run?
That's exactly what you should do. Of course, your scripts will not be named hello.py, hopefully. It'll be named, on the first assignment, you've got this weather data, and it should be named weather.py, right? But use the bin bash shebang, and you should be good to go on CSE. And again, what does that look like? Well, here, I'm just going to go ahead and grab the raw file here, right? And let's see. I'll put new, verify, save this as, this is my run.sh file, right? And I'll do this on the desktop here. Right? And I also need, say, a hello world file, right? So, oops. So new hello world.py, or I'll save it as hello world.py, and I'll do that on the desktop as well. Right. Now that's obviously not Python, so let me go ahead and increase the size here. For those that know a little bit of Python already, you're going to be helping me out throughout the day. How do I print something in Python? Is that correct? Nope. Well, it's correct for Python 2, but that ain't going to work in Python 3. There is no print directive, or whatever they want to call it. There is a print function, method, whatever they want to call it, and then you can pass in a string. Right? There is string concatenation. Oops. String concatenation, what is it? Plus, right? So actually, let's go ahead and go I'm going to go to the desktop here. CD desktop, right? And there's where's my hello? There's my hello world.py. So Python hello world.py. Right? Hello world, right? So you can use string concatenation. Another way to do it in Python 3 is comma delimited lists. That'll work as well. Oh, oops, sorry. No, that will be, oh, I don't know why it's doing that, but whatever. It should be like this, right? Maybe it's because I put a space there? No. I don't know why it's, oh, you know what? Which Python version? Huh, that's why. That's 2. So let's not do that. Let's go. Well, like I said, this is my own personal computer here, but this is basically what CSE would do as well. So let's go ahead and go with Python 3. Make sure that it's there. Great. I don't know what they're up to right now, but I think maybe 3.9 might be out there. I'm not sure. But Python 3, and then we'll run that hello world script. Yeah, much different, right? 2, 3 are not very compatible with each other. 3 is certainly not backwards compatible. There are things that you can do in 2 that you cannot do in 3 because they've been deprecated. All right. Another way of doing this, Pythoners. If I've got, how do I create a variable, x? Do I need to go int x equals 42, semicolon? No semicolons in Python. Python is a scripting language. It is dynamically typed. You don't have type declarations, right? So what if I wanted to print hello world and 42? Uh-oh. Let's try this. Nope, you can't do that. Plus is string concatenation, right? Only string concatenation. If you want to take something that's not a string and concatenate it with something that is a string, you need to do an explicit cast to a string. Right? And now you can do it. There we go. Hello world 42 at the end. Right? What's another maybe better way of doing this? Well, let's try this syntax. Right? That'll work. Right? And now you don't need to explicitly typecast it over to a string. Does anybody? All right, Pythoners. Now we're going to show your true chops here if you're real Pythoners. What is that? That's a formatted string, right? And so now how can I print X right in the middle of all this stuff? Close. This will be auto formatting right here, where I put curly brackets and then embed the variable name. And this should just print out exactly what it was before. But if you wanted to print out placeholder values, 42.5, it'll automatically do a floating point number, but can you do that? Now this is the limit of my knowledge. Somebody help me out. How do I do like 0.4x? I don't think you can do that. Nope. How do I do that with these formatted strings? Anybody know? Asterisk, is it? Like this? No, outside right here? Yeah, 4, 4, like that. Okay. And then not that, I assume. Nope. Maybe it has to be inside. Oh, hey. Well, no, that's an expression. It's 4 times 42.5. So I don't know. You'd have to look that up, right? If you want to get it down to an exact science where you are printing out a certain number of columns, there is a printf functionality. It's just that I don't know how to do it with the formatted strings like this, right? Okay, well, there's my hello world program. There's my run.sh program. Of course, I will need to change this to hello world, right? That's why we don't care what you name your scripts. As long as it is run.sh, it will run on the CSE server. Whatever you put in this, right? You could put compile commands into this. You could put, don't put malicious stuff in it, of course, because it'll run, but it'll only run on that course account. And then it's just me fixing it. These are pass-through arguments right here, right? In fact, let's go ahead and print those. Print sys.argv. That's arg vectors, right? Is that going to work, by the way? It's not, but I forget what we should do. There's the raw. How do I actually print these? Yep. Okay. It is sys.argv is a vector, so it's going to be a list in Python. Python has several different collections. Let me go over here. There is a list collection, so A is equal to square brackets. They're 0 indexed, and you can go 1, 2, 3. Right? You can also even mix types, I believe, but you don't want to do that in general. So let's go ahead and just go with 1, 2, 3, 42, right? Just to make sure that it's doing something else. What other types of built-in collections does Python have? Sets or tuples, right? So hello world. Right? That's nice. You can treat it like a list. It's going to be 0 indexed. But what you can do is then you can package up variables. For example, if I want a pair, I'll go x and y, 100, right? And I can do a pair is equal to x comma y. I can package that up as a pair. And now it's a tuple. You can treat it like a list, get the first one, get the second one using 0 indexing. What else is there? I mean, there are a whole bunch of libraries out there that allow you to do things, but there you go, dictionary, right? Curly brackets give you a map, basically. No, Python calls it a dictionary. All it is really a neutered map. Where you can use anything that is hashable as a key. For our purposes, think of that as being an integer or a string and a value that you point to. So help me out on the syntax here. I think it is hello maps to, is it colon, right? 42, comma. And then you can use variables like 10 maps to world. There we go. What does that look like? Let's go ahead and print C. Right. It's not going to look pretty, but okay. I hope to get to that later. That's all right. We will get to that later. How can I get rid of stuff? What's a comment in Python? // Nope. Hash. Right. There we go. So there we go. Hello maps to 42, 10 maps to world. How do you access individual elements? I want the element that hello maps to. So C sub hello. Right? What if you hash, or what if you map to things that don't exist? Foo. Right? Let's find out. Traceback, right? There is no key foo. How do you test whether or not a key is in there? To make sure that this is a safe operation. If foo, in the collection C, then and only then print it. Indentation matters. Here I'm using just 2 spaces. You have to be consistent about it. If I go also print blah, that is not part of the same code block, right? It has to be aligned. Watch. There. Indentation error. Right? It's not at the same indentation level. You either have to go in one or you have to make it outside of the if statement here. Note here that we've got a colon here. That denotes the next block that you need to execute. All right? There. So obviously this is not going to print foo because, or it's not going to print the element because foo is not a key in there. Cool. Anything else to add, Pythoners? Cool tricks. List comprehensions, of course. We'll talk about that in a bit. Yeah.
What about like else or something?
Okay,
like that,
good.
or
Else.
how does that-
Same indentation level as the if. Same colon. Print. Nope. Good question. What about else if? There is no else if. There is an elif. All right? Elif 2 is equal to 4, then print no way. All right? Now which one of these is going to print? Nope, because none of those are true. It is elif. Right? Colon, everywhere. Colons. Right? This was giving me problems before. Why? Because sys is not automatically part of the language. I have to import it. That is short for system. It's just a library of stuff. How do I bring something in Python? Import. Exactly what I just said, right? Import sys, right? And once I've got that, now I can use that sys. And in Python, like most dynamic programming languages or scripting languages, the first command line argument is the script name. In this case, hello world.py. If I gave it additional command line arguments, 1, 2, 3, here, 10, 20, 30, X, Y, and Z, then those are all going to be passed in as a list. So how do I determine the size of a list? Printf, or print, sorry, number of command line arguments. Len is length of sys.argv, or argv. Actually, I think it's, you could also use args. Let's find out. I'm not sure. This is a good question. Nope, it's argv. There, number of command line arguments, 7. 10, 20, 30, X, Y, Z, and then of course the script name itself. All right. So that's good Python so far, but it's kind of just, a really quick introduction to Python. Let me go back to what I originally wanted to do here and show you the hand-in process. I'm going to go ahead and hand in both of those two things on the desktop here. Run.sh and what did I call it? Hello world.py. Great. Those are both in there. There's a bug here that it is actually up there because it knows the size here. But now let me go over to the WebGrader interface. And I'm going, oh, nope, never mind. This is for the regular class. I don't know whose section that is either, by the way. But I will go ahead and go with 310H. Oops. There we go. 310H grade. There we go. And there's that hello world that you can go ahead and test right now to make sure that this entire process works, that you can actually get a script to run. All it's going to do is run exactly what you put into your script. Right? And in this case, it's all that crap that we just did. Right? Okay. And by the way, it changed the number of command line arguments here because I think, yeah, we put in command line arguments. This was some input to the run.sh file. Right? Questions on that so far?
I don't think I was looking when you put those command line arguments
No, that's the script doing it. That's the script doing it.
Okay. Do you have to have one run.sh file for each of your programs?
You will always turn in a run.sh file. Yep.
Assignment?
For each assignment. Yep. And there are that many assignments. Programming exercises.
Hand them in like per program and not.
Yeah, because presumably you would name your script something different, right? You would name it, don't just name your script, my awesome script, my awesome script, my awesome script, right? Weather.py, hampath.py, whatever. Okay? Good. All right. Remember, we are online. If you've got questions, go ahead and ask through Piazza, or I've got the YouTube chat going as well. All right. Let's go ahead and do something a little bit more substantial now. I'm going to go ahead and get rid of this. I'm going to go ahead and get rid of this. Yep, I don't care about that. What I want to do is I want to take this algorithm here and I want to write it in Python. That given a bunch of points, I want to determine the two closest points. So suggestions on how to get started here. Obviously, I'm going to need a source of points, right? And what I've done is I've created randomly 1,000 points over here in a file named input001.txt. Okay. Let's go ahead and find out what are the two closest points in that data file right there. Right. So first step is we're going to have to read that file in. Yeah, I'll go over here. This is just demo. So let's load up that file. Now, with any programming language, you don't want to just write one big giant script. Right? You want to separate things out into their own functions. How do I write functions in Python? Most def, right? Define, and then we'll call it load points, right? And now whatever you put in this, no opening, closing curly brackets in Python, whatever you put in this is defined by this function. You can call this function over and over again. I'm going to pass in the file name that I want you to load up and give me those points. Also, no return type, unlike C or Java, where you are statically typed. Python is dynamically typed. You can return whatever the hell you want. Right? Sometimes you can return a string. Sometimes you can return a list. We're going to return a list here of tuples. Right? And we'll understand what that means here in a second. So, by the way, if you want to, you can do proper documentation. Proper documentation is going to be as per JEP 186 or something like that. It's a standard in the Python working group or whatever on how to do doc style comments. They don't actually go above the the name of the function. They actually go inside. Quote, 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 3 quotes is a multi-line string. It's not a comment. It's essentially ignored as a comment. It's just a string that exists right there, but you never put it into a variable. So it's basically lost. So it basically has the same idea as a comment. Right? This method loads up the points from the given file. And so I would need to put that in as a file name. All right? ... Right? You can put in annotations and a bunch of other stuff too to get doc style comments like you would in C, Python, or Java. So my computer science 1 course is C. My honors course is C and Java. This is going to be Python. I think I don't have to keep PHP in mind until next semester probably. Right? All right, so correct me if I keep going back and forth on all this stuff, right? Okay, so this method loads up the points from the given file. Help me out. How do you read files for those who know Python already? Okay, and it looks kind of familiar. It's not fopen like it would be in C or PHP or something like that. It's just simply open, right? File name, and but it does have the same format. The file name, which could be a complete path, and then you want to open it up for what mode? Reading. Right? there is this nice little, you can read line by line if you want to, but there's this nice little function called read lines. Oops, I think it's lowercase. There we go. So that file that I just opened, I want all those lines. Lines here ends up being a list of strings. Each string is one line of the file. Since I've got this formatting here, where the first one is the number of pairs of points, the number of lines that you should read, I can kind of ignore that, right? I don't need that. All I need to, well, I could, yeah, or I could go through the rest of it. I just want this line, and I want the first number, that's the x coordinate. I want the second number, that's going to be the y coordinate. Right? So how do I go about processing that now? So what I want is for each line after the first, ... So a for loop in Python.
Oh, I have a question.
Oh yeah, go ahead.
So if you read the first two lines and then you read lines, will it begin in the third line or?
Good question. RTM. Read the documentation. Read the manual. I have, off the top of my head, I have no idea. The question was, if you read one line and basically toss it out, then read lines, does that start from the second line, or does it read all the lines regardless? I don't know. I have doubts that that's actually a cursor, so I don't think that that would work. But I would not give even odds on that either. Right? All right. So, well, what if I didn't ignore that first line? If I just want to iterate it over each line? A for loop, right? For line in lines, right? That's kind of like a for each loop, right? For each line in this list of lines. What do I want to do? I want to split it out. So values equals, I think that there is a split function, split line, and on the, is it commas or was it white space? It's white space. So you can do something like this, okay? And what else? Then I would need to put that into a result. So let's go ahead and create a result here. How do you initialize an empty list? You just put empty square brackets. Right? And then once I've got those values, I'm going to go ahead and results.append. That's how you add something to the end of a list. Okay? Results.append. And I want to append a tuple. I want to, ideally what I want to do is I want to put in an x and y coordinate here, which are both floating point numbers. Right? These values here, that is a list of strings. So I want to coerce those. I want to be able to translate those into floating point numbers. And I can do that by going values sub 0, right? That's the first one. But I want to convert that to a float. How did I convert something to a string? str. So how do you think I convert something to a float? Float. Float that. Float this. Value sub 1 for the second one, and you're good. Right? Now that's adding a tuple. So this ends up being a list, returns a list of pairs, tuples, of points from the file, to file. All right. All right. Okay. Does it work? Well, let's try it. So let's go ahead and get the points is equal to get, what was it, load points? Load points. And for the file, I think it's in the same directory here, input 001.txt. I'm just hard coding that. Of course, you could read that in as a command line argument, right? All right, and let's go ahead and print points. Oh, no, I don't care about that anymore. Okay, there we go. So there's my input file. Here's my demo. Is that my demo? Nope. I was in the right place. Copy, dev, input here. All right, now I've got input.txt and I've got my demo file that I've been working on. Just making sure that it's the correct one. Yep. So Python 3 demo. There we go. So a couple problems here. First of all, it doesn't look like there is a split function. So what do I do? Immediately go into Piazza. What's the split function? Or maybe cry. Or maybe use our old friend Google, or in this case DuckDuckGo. Don't use Google, use DuckDuckGo. What split function in Python? There is a split method, right? But you have to split the string, right? Okay, so that's how you do it. Line dot split, and then it looks like the default is white space, so I don't even need to do that. I think that you can override that, can't you? Yeah, the separator and then the maximum split, kind of like how other split functions work. Okay, so that takes care of that. There's still another issue here. Results, ooh, not results. Results, fine, there we go. List index out of range. All right, what's going on there? The very first line. I'm expecting 2 tokens back, I only get 1. So back to the drawing board. How do we skip that first line? Pythoners? No? 1 to the end. All right, now read that syntax. Lines is a list. Lines with a with the brackets there says I want only a sublist of that, starting at index 1 all the way to the end. So 1 colon nothing to go to all the way to the end. If I wanted 1 through 10, actually I had 1 through 9 because it's inclusive, exclusive. So 1 through 10. Okay. If you want from the beginning all the way to index 9, you can use that syntax. I want 1 all the way to the end. Right? When I do that, I end up skipping that first line. Oops. What was my next mistake? Python is a dynamic programming language. There are no compiler errors because there's no compiler. But if this were C, there would definitely be well, it wouldn't be a compiler error, it would be compiler warning. If this were Java, this would be a compiler error. Yeah, you can't return. If I'm going to expect a return value, I actually need to return something. Return the results. Right? Otherwise, what was I getting back by default here? None. That's kind of Python's null. None, none type. Those are both supported. Right? There's all the points. Lots and lots of points. 89931516. 89931516. All the way down to the bottom. 4557. 4557. I'm convinced that I'm reading all the points correctly. Right? There's the last point, and there's the last point in the file. So I'm convinced that this is working. We've loaded all the points, but now instead of printing them, let's go ahead and determine which ones are the closest ones by using this algorithm over here. Okay? Again, I'm going to be using some good programming practice, and I will go ahead and give these points to another function that's responsible for finding the 2 closest pair. Right? So another function, def. Does order of functions matter, by the way? Nope. In fact, you can use a function, I believe, before you even declare it, because there. Let's verify that. Make sure that I'm just not blowing smoke here, right? Nope. It does matter. Sorry, I was blowing smoke. Right? But I thought it hoisted it. It's not like PHP, so that's not true in PHP. PHP, you can use a function before you've declared it. Because it goes through, the preprocessor goes through, hoists all the functions up so that it knows what functions are there, so that then it starts executing the script to make sure it already knows about all the functions. That's not true here, apparently. Okay? So def, find closest pair. What should I call this? Closest compare. Right. They do follow a convention here of lower camel casing in Python for function names and variable names. So I do like that. Python is not my favorite programming language. Right. But I'm going to go ahead and give the points over to that function. All right, help me out. Translate this into Python. So min_dist, I'm going to go ahead and min_dist equals some very, very, very large number. By the way, is that correct Python? Yes. You can do arbitrarily long and large numbers. This will work. I could type here all day and that would still be supported. Python 3 and 6 and up, not before. Right. But I don't want a very, very, very large keyboard mashing number. What do I want? Math.inf would be good, except that the math library is now something that I have to import if I'm going to use it. Right. Make sure that I spelled that correct. Yep, it's happy. So math.inf. Anything will be less than math.inf. There is a negative inf, I believe. Anything will be larger than negative inf. All right, what next? For each pair of points. So I don't know how to do that in Python cleanly or in a Pythonic manner. You'll hear this term all the time, and I'll use it all the time. You're not doing it the Pythonic way. You can have a traditional for loop. A traditional for loop would look something like this. For I in the range of 0 up to n. Right? Now this is an idiomatic for loop here in any other language. For I equals 0, I is less than n, I plus plus. Right? What range does is it gives you basically an iterable list of index values. 0, 1, 2, 3, 4, all the way up to n minus 1. If I did it like this, it would go 0 up to what? 9, right? So I don't want to go up to n. I could do n here, but what would n be? The length of the points, right? And then I can have a nested for loop. For j in the range of 0 up to length of points. But is that going to do what I want it to do? If I go point 5, or the fifth point and the 10th point, I don't want to then go to the 10th point and the 5th point again, right? And neither do I want to say that the 5th point and compare that to the 5th point, because the distance is always going to be 0, right? So I don't want to start my range at 0. Where do I want to start my range? At I plus 1. And I can go 1 less over here. Okay? You can change this first for loop to be a little bit more Pythonic for p in range in points. Right? Now you're iterating over all points, but now you need to do all the other points after it. But I don't know what the index of p is. Right? So you're not going to be able to do this in a very Pythonic manner that I know of. If you out there have some clever ideas on how to do this a little bit better without having to generate all possible pairs, which we will eventually do, then let me know. But otherwise, I want to compare the ith point and the jth point. What is their distance? All right. Remember this distance function over here, or this distance, Euclidean distance, square root of the x difference, squares, the sum of squares of differences, right? That sounds complicated enough that maybe we should put that into another function. So def distance, Euclidean distance, right, of point A and point B. Right? And I will return math.sqrt, looks familiar there, of a sub 0, that's going to be the x value of the point A, minus b sub 0, that's the x value of point B, of the second point, right? That's why I'm not using x and y as my input values. Right? I could use p and q for point P and point Q, but I'm just going to use this. I could do math.pow if you want to, but it's just a square, so there you go. Plus the y value, which is at index 1. Right? Again, you can treat tuples like lists. Get the first one at index 0, the second one at index 1. Right? All of you that know Python, is this boring? Go. No? No? Okay. All right, there we go. There. There's the distance. So I want to compare the distance. D is equal to distance of the ith point, so that's going to be points of I, and points of j. Now, if that distance is less than the minimum distance I've found so far, then I will need to update the minimum distance and also create a tuple of values here. Right? So if d is less than min dist, then min dist is equal to d. And I'll go ahead and have these two closest points here. Closest pair is equal to, I just need points. In fact, I'm going to take this. Points of I and points of j. I'm creating a tuple out of that. And at the very end, I will return closest pair. I don't have to worry about initializing that in Python because the first two pairs that I find are going to have a finite distance. And so that's going this if condition here is going to execute on that first iteration no matter what. Right? Let's see if this works. Closest pair. Is that a good idea? It's certainly going to be okay, but what's a better name for that variable? Because I've already, why is it not a good idea? I've named my function closest pair. In certain programming languages, you can start to confuse function names and variable names. And in fact, in certain programming languages like C, if you have a function called closest pair that's in the scope of the immediate code, then closest pair is already reserved, and that's a pointer to that function. So you would not be able to use that variable name at all. Right, without confusion. Right. So, closest pair, I don't know. Again, what are the two most difficult things? There are only two difficult things in computer science. What are they? Cache invalidation and naming things. Okay, I like that. I like that solution even better. Why? Because it's a verb. All right? Get closest pair. I like that. There. Oops. Okay. I can reuse that variable name down here because it's out of scope. Get closest pair of points. And let's go ahead and print closest pair. And I have no idea what the answer here is going to be, but hopefully it works. Oh, no, what is it? Help me out. What? Yeah. It does. Oh, okay. Case sensitive. Lowercase inf. There we go. There's the closest pair. It looks close to me. I mean, 2457, 2437, and then the 9,000, negative 9,000s kind of agree. How do I know? Okay, well, go through by hand and do 1,000 by 1,000 comparisons, a little less than that. So you don't have to do the full million operations, but there you go. What I'm going to do is, let's see. I'm going to give you another thing to consider here. I'm just going to cut and paste this. Let's not load up points from a file. That was your Python lesson for the day. Let's go ahead and generate a bunch of random points. Get random points, and n will be the number of points that you want. So the way that you can do random stuff is uniform random. We do have to bring in that library. I believe it's just random. There we go. So what I'm going to do is I'm going to generate, say, 1,000 random points. So instead of calling instead of calling load points, it'll say that points is equal to get random points. Let's go with 1,000 random points here. Okay? And let's go ahead and run it again. And you can see that it's randomized each time, but I'm fairly certain that those are pretty darn close. So I have a really good suspicion that I could, of course, change this to 3 random points, and then I can do everything by hand very, very easily, right? Maybe even 4 or 5 random points, and then verify everything. Or I could manufacture my own test case where everything is really, really easy. Take 10 points that are very, very large numbers away. Then take 2 more points that are 0, 0, and 0, 1, that are guaranteed to be only 1 unit away. Right? You know exactly what the answer is when you constructed that test case. That's how you should construct your test cases. Right? Python, 3, so 5. So 1,000. How long did that take? It was human perceptible, right? There's a slight pause there. Okay. I don't know how long it took, but we can find out using the time library. Right? It was perceptible, but it wasn't. It was too fast for me to say that it was 0.05 seconds or something like that. So let's go ahead and use this time library here. And I'm going to just cut and paste this. And call my function here. Forget about that. Forget about that. Forget about that. All right. Oops, I need start and end. So start and end time.time. Oops, there we go. That's just getting the system time before you start that function, getting the system running that function, then getting the system time after that function, and printing the difference. And it is in seconds, so that was 0.3 seconds, 0.37 seconds. It's pretty consistent. All right. So let's kick it up a notch. 1,000 points, let's go up to 10,000 points. How long is it going to take now? Before it was about 0.3 seconds, let's say. Predict. 30 seconds?
It's not linear though.
Yeah, it's definitely. So if it were linear and I went up by a factor of 10, how long is it going to take if it were linear? 0.3 times 10, which would be 3 seconds. We're well beyond that now. It is not linear. What is it again? It's quadratic. So if I go up by a factor of 10, from 1,000 to 10,000, what is going to be the slowdown? Factor of 100. So 100 times 0.3 seconds, roughly 100. There are some other terms in there because, again, it is n choose 2. And so you are going to have like that divide by 2 there. But ultimately, it was almost dead on there, right? What if I went up to 100,000? Should we sit here and wait for it? 36 seconds, 100 times slower is going to be an hour, is it? Or, yeah, it's going to be an hour, right? All right, no, I'm not going to wait for that. What about 1 million, or how many is that now? 1 million. So 100 times an hour is going to be 100 hours. 10 million. 100 hours times 100 is going to be 10,000 hours. How many of them? What's that?
A lot of time.
So 1 million hours to years, maybe? That seems too much. It's probably, no, it's 114 years. And even my perception of time, our perception of time as humans is completely off, right? So if I went up to, what did I do it? So 10 million, that's going to run for 100 years. Now I've asked for a new laptop because this one is slowly dying. There's no speaker. The right speaker is dead. the butterfly keyboard has been, this is the third butterfly keyboard that is also now dying. And also this overheats if I try to do too much of it on OBS, right? So no, this is not acceptable. This algorithm that we developed, is it a good idea? Nope. Even though it's polynomial, right? That's n squared, right? What's the problem with n squared algorithms? Is 10 million a big number? Nope, not by computing standards. No way is this acceptable, right? We have to look for something else. But what we're doing here is basically brute force. And on Friday, we'll talk a little bit more in detail of what we just did over the last 2 days and talk about what we did was we generated combinations. How do we do that more in general? Why do we not want to do that in reality? And all the consequences thereof. I mean, you're seeing the consequences right now, right? There's no way I'm going to let that go. All right? I will see you on Friday then.